Okay, so for the solutions of these, I don't know that there's any solution necessarily on the website like solving these things, but if you look in the lectures, all of these, like the circuit exercises, are solved as PowerPoints. And the cool thing about PowerPoints is that it lets us, we can do things that are really, really messy on paper. We could just hit the right arrow, right? So if I hit the right arrow, you can see that suddenly I got lazy and I made all the ammeters. I took them out of circles and stuff like that. But that's okay. We can read that. So I think we agreed that the 10 and the 12 was a 5.454545, right? And then I think we got as far as this, yes? Yeah. But that's a 5.9583333333333333333, right? It's still not solvable, but it's close, right? Because we still need to take those guys, and those guys are connected how? Those are series, 9 and then that and then that. That's, they don't joke, right? And we're almost solvable now. We're almost solvable now. There's some laughter there. Okay. Oh, there you were laughing about that joke. I won't say that joke on YouTube. Okay.
Oh, we're on YouTube still?
Yeah, we are kind of. You know, it's okay. I'm sure it didn't hear you though. Okay. But anyway, there's there we got 8 ohms and we've got 20.4, and those guys are connected how?
Parallel.
Those guys are parallel, right?
Yeah. Bang.
And then finally, this is something that we can solve. Now, if you can't solve a series circuit, you're just lost, right? You go, I still can't solve it, right? Okay, but if you can, you know that well, oh my God, all these things, right? Okay, so the first thing we do is we add up all the resistors, and so 6 plus 7 plus that guy is that. The one current, and series circuits have one current, many voltages, right? The one current is 1.9736 amps, right? And that's what A2 reads because it's in the path of that current, right? And then we measure all the voltages. If we wanted the voltages across these guys, it's just I times R. And that's just what we do. And I'm hoping that we're at a point where we don't have to think about that. It's just what we do when we get to a series circuit, right? So most importantly is we've got to find the voltage across this guy. That's not really a resistor. It's just like a thing that we've reduced. The question.
So how do we know what voltage is towards what resistor? Because like sometimes they're like that and it goes exactly over it, and sometimes it's
Then we got to look at the original one. So let's go back. The question was, how do you know what voltage goes with what resistor? So let's look at this thing here, right? So if we look at this voltage here is actually across this whole mess on the right side, right? This guy is across just the 9 ohm, yeah? So go upstream to downstream, there it is, right? This guy here, it's like, what is it across? Well, it's actually across these guys here. As together though, not just the 11, but the 11 and the 13, right? Because as it's hooked up, they're inseparable, like that, right? And then this guy is not just the 12 or not just the 10, but the 10 and the 12 together, because they're in parallel. Because these guys are in parallel as they are right there, right? And so they're going to act in parallel. So I can't just look at one or the other.
Is that why V went up?
Yeah? Yeah. And that's because parallel circuits have one voltage, not two, right? I mean, it really is across the 10, and it really is across the 12, but it's across both. And since it's a parallel circuit, and since parallel circuits have only one voltage, right, they're going to share the same voltage. And that, by the way, is how we're going to solve this. We're going to use this voltage to figure out what A3 is, right? And we're going to use this voltage to figure out what A4 is. Yeah? So let's go back to where we were. So we're here, we're there, right? And then we solve this, and we really want to find the voltage across that reduced part, right? That's what we're really after. And we find that. That's 11.3432, right? And then we go boop. And now we've just gone back, right? And we've gotten rid of the rest of the circuit because it confuses us and it's wrong and it hurts us. Okay? And Gollum. Okay? And this is a parallel circuit, and I'm hoping that a parallel circuit is also something that you can solve without thinking about it, right? So we've got this guy, and I know that I can find the reading on that ammeter by just going V divided by R, and that this current here doesn't depend on the current there. And if you can solve a parallel circuit, you understand that, and if you can't, then you can't understand that, right? But it doesn't read, A1 doesn't read this current here, and it doesn't read that current there. It reads only this current here. And parallel circuits have one voltage, but many currents, right? And so this current is just simply that voltage divided by 8, and then we're ready to move on. Moving on, by the way, is just to ignore the 8 ohm resistor, right? Okay, so it's like, let's get rid of that, right? Okay, so now we've got this, but is that just a 20.4129 ohm resistor?
No.
No, it's actually something more, right? It's actually, it hurts us, right? Okay, so we don't unpop it all the way, right? We just make it this, yeah? So that same voltage is across all of this. What kind of circuit is that? That's a series circuit, right? So we're going to solve that series circuit. How do we solve series circuits?
Panic.
We panic. We leave. Add all the resistors, right? So that's what we're doing here.
Liar.
9 plus boop plus Betty boop is this. We find the one current to bring them all, and in the darkness bind them. In the land of Mordor, where the shadows lie. No. We find the one current, and then using the one current, we find all the voltage drops. There's a voltmeter across the 9 ohm resistor, so that's the one current times 9. There's a voltmeter across, and I think that's the 10 and the 12, right? Isn't it? The 5.4545, right? And that voltage is 3.0310. Then we find the voltage across, and this is the 11 and the 13 down there, yeah? Right? And that voltage is 3.3110. And the only difference between this and the skill set is that there's the skill sets you'll have just one of those, right? This one's got 2, which makes it, I think, well, kind of a lot harder. So the skill sets will be easier than this one. Harder than 3A though. Okay. So are we good so far? Did everybody understand? Does everybody understand where we're getting this? Yeah, no?
I'm not getting V2.
What?
How is V2 all of that? There's like in the full diagram.
V2. Yeah, no, I know. So it's like, there's the whole thing, right? So how is V2 all of that? Notice that V2 is connected. If I connected it right there at that junction and right there at that junction, there'd be no doubt that it was across the two of them in parallel. But this is all the same piece of metal from here to here. So it doesn't matter where I hook this end of the voltmeter as long as it's on anywhere on this piece of metal, right? Because all that voltage is the same. And this guy here could be connected anywhere on this piece of metal, right? I connected it there because I'm lazy. And I didn't want to make a little bendy wire. Yeah.
Do you have some like practice circuits that are the same level as this one?
Say it again.
Do you have some more practice circuits that are the same level?
You know, I don't. Which is sad. I should have some more. Yeah. The question was, do I have more practice circuits at this level? And sadly, I don't. Yeah, almost as hard as this, right? Okay, blah, blah, here we are. Whoa, 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 whoa. Right? Okay, so we get to this point, and we get all these voltages. With this voltage, we're done. That's just a resistor. But these guys are not just simple resistors, right?
No.
Yeah, it's kind of obvious. It's like one of these things doesn't go together, right? So these guys are the ones that we're going to have to expand, and we'll just have to do 2 expansions. One using this voltage, one using that voltage. Okay, so this is, I must be doing the 5.4545, which is the 10 and the 12, right? Okay, so that's really this, yes? So what kind of circuit is that?
Parallel.
That's parallel. And does this current depend on that resistor?
No.
Well, in the circuit it really does, but if the circuit is just this, and that's what we're pretending, it doesn't, right? This current depends only on that resistance. Yeah? Right? So this one's going to be...
Is that like the thing you were talking about, the box where you draw and then it goes through that line?
Yeah, it's the parallel one.
The last one depends on all of them. But like going like
Right. So where this ammeter is, it measures only this current. If we put it there, it would measure both currents. Right? If I put it here, it would measure only this current through this guy. Yeah? Right? But where it is, it's only measuring the current through the 10 And we can just go voltage divided by 10.